If you find this video helpful, like it, share it. If you didn't like something or have suggestion, write in comments below. Support and subscribe SS Physics. What is phasor? If we add two waves with phase difference 0, resultant amplitude is addition of amplitudes. If we add two waves with phase difference 180 degrees, resultant amplitude is subtraction of amplitudes. If phase difference between two interfering waves is other than 0 degree or 180 degree, what will be resultant amplitude? Maybe a formula. What if we add more than two waves with different amplitudes and different phases? Question becomes tricky. Phasor diagram solves this problem. What is phasor or phasor diagram? It is addition of amplitudes using vectors. So here we will draw waves and here we will represent these waves by a vector. So this is the first wave. So this wave can be represented by a vector. So here the amplitude of the wave is represented by magnitude or length of the vector, and phase of the wave, that is starting phase of the wave, is represented by direction of the vector. Let us take example of second wave. Now the difference between the first and second is only of amplitude. Hence the representation of this wave is like this, the vector with less length or magnitude. Again let us take the example of third wave. Now what is the difference between first and the third wave? It is the phase difference phi. So it can be represented by a vector with the same length but which is inclined to the horizontal direction by an angle phi. Now if you add the two waves, let's say first and second. So there is the first wave vector and the second wave vector. The resultant is this. So here resultant vector indicates the resultant amplitude. So this is the addition of these two waves. Now let us add 1 and 3. So this is first and this is the third wave. Here the phase difference between the first wave and the third wave is angle phi, and therefore we will draw like this, and the resultant will be simple addition of these two vectors. Now add all 1, 2 and 3. So what we will get here? So first wave, second wave and the third wave and their vectors. Resultant is this. So here we have added three waves with the different phases or amplitudes. Now this particular phasor method is very useful if we want to add large number of waves with the different phases and different amplitudes. Not just the three waves, but we can take here 10 waves, 50 waves, 100 waves, n number of waves we can take here, and we can find the resultant amplitude of all these waves. Phasor method is useful to study Fraunhofer diffraction at a single slit. If you find this video useful, like it, press this button to subscribe. Press this to learn more.